Are we live? Hi everyone, good evening. How are you? How is your evening going? Enjoying Friday? Hi Prakhar, excited for this. I'm also excited to teach you right now. Hi Prashid. Okay, let's get started. Hi everyone. Hi. Okay, let's get started. Today we are going to learn a very interesting topic called databases. Okay, what are databases? Databases is a base where data resides. Okay, all the database right now that we have are divided into two types. One is SQL based database and one is no SQL based database. Okay. Do any one of you have any idea on SQL and no SQL? Do any one of you have idea on SQL and no SQL? No? Okay. So in SQL, we have something called tables. Okay. Just like an Excel sheet. Okay. In NoSQL, we store objects. Just like in APIs, we were using JSON, right? Or JavaScript objects. In NoSQL also, we store objects. Okay. When do we use SQL and when to use NoSQL? Okay. First of all, remember this. SQL uses tables, NoSQL uses JavaScript objects. When do we use SQL? SQL is more secured by default. Okay, it is relatively old. Okay, and when we have defined structures, this is the most important thing. We have defined a structure, then we use no SQL database. Sorry, then we use SQL database. When do we use no SQL database? It is lightweight by default. Okay, this is relatively new. And when we do not have a defined structure, when we do not have defined structure, then we use NoSQL database. Okay, mostly it comes down to this defined structure and not a defined structure. What are defined structures and what are not defined structures? For example, if you're creating Facebook type of application, okay, where for each reply somebody can post a reply to that, or somebody can post a reply to this one, this reply, or somebody can post a reply to this reply. Okay. In this example, do we know how many replies can we have? Is this predefined? A person can reply to any of the replies above, right? Is this defined structure? No. This is not a defined structure. Okay. So here, what would you use? What would you use over here? We will use NoSQL database. Okay. But for example, if you're creating a table for user, right? We already know what are the things that we require from user. For example, name, email, uh, date of birth, etc. Okay. We already have a set of prerequisites of what we require from the user, and this is not going to change for a very long time. Okay. In this case, Does it look like a table to you? Does it look like a table to you? What would you use over here? We would use an SQL database, right? We would use an SQL database for defined structures and no SQL database when there is no defined structure. You can use both in the same application, but mostly people use SQL databases. Okay, until and unless there is no other choice to use no SQL database, we use SQL database. Okay, we will also be using SQL databases. Now, what are SQL databases? Everything is same. Everything is same in SQL and NoSQL database. Just the way uh, they save the data is different. Okay. Everything you will learn in SQL will also be applicable in NoSQL. Everything you will be learning in NoSQL will also be applicable in SQL. Okay. There are very small differences. It is just the way they store the data. Okay. For example, if you're saving replies on replies, we have, say, email. In this, we have a reply. Okay. In this, we have a reply again. In this, we have a reply again, and so on. This is the way NoSQL saves something, saves the data. Okay. And in SQL data, we have, say, name and email. It will store it like a table, like name 1, name 2, email 1, email 2, etc. Okay, all good till here? Any doubts? Some examples of SQL databases are MySQL. Maybe you may have learned it in your college. SQLite, Postgres, etc. Some examples of NoSQL are MongoDB, okay, CouchDB, PouchDB, etc. Okay, what are the significance? What I have always told you, there is some problem that anybody is trying to solve. Okay, if there are different technologies, they're trying to solve a different thing. Okay, so SQL, what is it trying to solve? It is trying to solve structuring of data. It is trying to solve security of data. How is it secured? Because it is not directly going to JSON format. Okay, JSON is relatively less secured. JSON is basically a text file only. Any file with .json after it is simply a JSON file. Whereas in this, you will find a .sql file. Okay, there is an encryption already made on .sql. You cannot directly access the data in .sql. Okay, it is not very simple. Whereas in .json file, you will simply find the whole JSON over there. We have seen examples of JSON file, right? For example, in package.json, this is a simple JSON file. You can find the whole data over here. But in SQL, you cannot find the data very easily. It is already encrypted. Okay. Now you understand when to use SQL and when not to use SQL, right? There are very small cases where NoSQL databases are useful. Okay. Now, let's understand the overall structure or how do we create a database. Okay. For example, if we talk about SQL database, first of all, our first step would be to create our database itself. Create the database itself. In a database, just like a server, we create multiple APIs, right? In a database, there can be multiple tables. Okay. So this database is a basically collection. For example, you use folder structure, right? What is the best way to divide folder structure? You have a C drive, then in that you have uh, say Devsnest folder. In that you have say front end and back end, right? This drive represents a database. Devsnest represents one table, and the content inside it can be treated as columns. Is this all clear till here? We have a database. Inside that, we have different tables for different purposes. Okay. For example, you are creating your college website. Okay. So one table can be of students' data. One table can be of classes. One table can be of schedule. One table can be of inventory, let's say. Okay. I have always told you to divide and conquer. The more you divide, the more you can conquer. Okay. So suppose if you have created everything in a single table, if you have created everything in a single table, what would happen? If you have created one single table in a DB, for example, your college, okay, what would happen? You cannot reuse this table in any other application, right? But if you have divided it into multiple tables, for example, users or students or teachers, you could have used the same table into some other application, right? So always divide and conquer. When we create our DB, just like this is very similar to creating a server. When we created a server, we checked for its connection, right? We have to check whether DB is active or not. DB is on or not. Okay. This is the second step. What would be the third step to create tables? But in SQL, I've already told you there is structured data. So you would have to create something called models. Models are basically the structure of table or column. Okay. So any model looks like this. For example, if you are creating users table, okay, what are the fields that it can have? It can have a name, right? It can have an email. It can have an address. It can have a date of birth, etc. Okay. Then you need to define any validations on the database itself. I've always told you three things: performance, security, and edge cases. So to handle the edge cases and security, if suppose somebody is trying to mess with your database on the database layer itself, okay, suppose it is not going through the API, they are trying to create something in the database itself, then you want to restrict them to mess with the database, right? So you have to define some validations over here itself. For example, there should be a string. Okay, there are many validator packages which allows you to write some specific validation, just like we wrote the validations of regex in our previous class, right? In the API level, we also write them in the database layer itself. Okay, always it's your responsibility not to have any edge cases left. Okay, some of the validations, for example, JOI is a package. It helps you to validate on the database layer itself. Anybody cannot modify your database until and unless it validates your validations. Okay, for example, a string of length 8 minimum. Okay, email is a string with at the rate and dot. Address is a string. Date of birth is of time. Okay, so you have to define. This is called a model. What is it called? It is called a model. Okay, so you're defining the structure of the table. Okay, then simply you can create the CRUD operation again. What are CRUD? What is CRUD? What is C denote for? Create, read, update, and delete. Correct? Awesome. Awesome. So you can also do the CRUD operations onto these databases. For example, if you have created a model named users, model is users. So you can do users dot create. This gives you a function just like we used express. This gives you a function in which you put the data and it is passed to your users, right? If you want to read, so you can simply use users dot find, okay, and put in a condition, for example, where your email is something. Okay, this is an example of read. If you want to find all the users with this email, so you will use users dot find all. These are just different functions what you can use to do CRUD operation. Okay, what should be the function name for update? Users dot update. In this, you have to pass two things. First of all, how do I find the user? Same thing, the where clause in over here itself. Okay. For example, where email is something and update. The update whatever the field to this value. Okay. What should be the delete? So users dot delete, and how do I find that users to delete? Okay. So basically these models itself gives you different functions to do the CRUD operation. Okay. Any doubt till here? Any doubt till here? Just like we learned in Express, here also same thing happens. We created router in this, right? We created router yesterday. We had router.get, router.post, router.put, etc. Similarly, you will find these methods over here. Users.create, users.find, users.findAll, users.update, users.delete. Okay? Model is basically the structure of your table. Okay, Ganesh, we will get to an example in some time. Today's class would be a small one because today is Friday and I want you guys to use Saturday and Sunday to learn about these technologies a little bit more, to read the documentation, to read some blogs, etc. Okay, that would be your homework for today. To read about two things. One is Express, one is Sequelize, what we will be covering today. Okay, I want you guys to utilize your weekend over to learn these things so that you are very, very prepared from Monday because we are going to jump into different type of projects. Okay, so today's class would be a smaller one. Be very prepared. Okay, okay. We'll come to models again when I am giving you an example. Okay, chalo. Okay. One thing more. Whenever you create a table, na, whenever you create a table, a default column is created, which is called ID. Okay. Whenever you create a table, a default column is created, which is called ID, which is some random numbers. Okay. It can be 1, 2, 3, 4 if you want. Okay. Or it can be any encrypted numbers. Okay. It can be any encrypted numbers or it can be a sequence wise also. It depends on you. This ID is a unique identifier of this raw data. Okay, this ID is a unique identifier for this raw data. So this ID gets saved also in cache, something called indexing. This also you have to tell the database that you have to do indexing. Okay, we will go into examples of indexing in later classes, but just to let you know. Okay, these IDs are unique identifiers of these rows. So for example, if you have my ID, either you can search via my email, okay, which is a little lengthy task, right, because it is not saved in my cache, or if you have my ID, say A1B, it would be much more faster to search me with A1B than my email. Okay, because these IDs are saved in my cache for faster retrieval. Understood? Did you guys understood this point? This is a unique identifier. Just you have to know this is a unique identifier for this row data. Okay. For example, I have name and email, name one, name two, email one, email two. Okay. This ID or row number, for example, we use row number, right? This row ID basically denotes this whole row. It is much more faster to retrieve anything from ID as compared to any data in other columns. Why? Because most of the databases store this ID, also create this ID and save it in cache. Okay, all good. What did Sandeep do? Okay, you guys are more familiar with the word schema. Okay, models are schema basically. Yes, all good. So what we have to do? First, we have to create database. We have to check whether database is connected or not. Uh, we have to connect to database. we have to create tables using models or schemas, okay? And then we have to operate on these models, okay? Operation can be operate CRUD on these models, okay? All good? I will wait for 1 minute over here if you guys have any doubts. Do you guys have any doubts? These things are very similar to what we have done yesterday for servers. No doubt, all clear? We just have 4 steps. Sumit, Ganesh, all clear? Okay. Just one more thing before we switch to code. Just one more thing before we switch to code. We are going to use something called Sequelize. Uh, Sequelize is something called ORM or Object Relational Model. Okay, we are going to use something called Sequelize. What Sequelize does is, we have seen multiple examples of SQL, right? Like SQLite, SQL3, right? MySQL, Postgres, etc. Right? We have seen multiple databases, right? What happens is the functions that these databases provide varies. Okay. For example, in SQLite, we would have update. The way to write the update function is different. In SQL3, the way to write the same update function may differ. In MySQL, the way to write the same update function may differ into this. Okay. What Sequelize does is it creates a wrapper around all these and gives you the same function, gives you the function that is same for every SQL based database. Okay. So we will have same update function being used for SQL, any SQL based database. Okay. It gives you a wrapper around these databases, which helps you to write a same function which can be used to different kinds of databases. So, for example, if your company is using SQLite right now, okay, and suppose they ask you to change SQLite to SQL3, okay, do you want to change your overall application? Would you like to change your overall application? No, right? Just for this simple change. So what Sequelize does is you do not have to change anything in your code. Simply just switch SQLite to SQL3. Okay, that is why we use Sequelize. Okay, everybody understood why we use Sequelize? Okay, should we jump to code now? Awesome, awesome. Now we have this example from yesterday. Can you guys see this? Or do I zoom more? Can you guys see this or do I zoom more? Zoom. Is this okay now? Okay. Now, just like we learned yesterday for servers, we required two things. We required Express, right? And we required bcrypt. Today also we are going to require two things. We are going to require something called Sequelize. We have learned what Sequelize is. Sequelize does not do any performance overhead. Okay, you can use Sequelize, no issues. Why I'm not able to type? One second, guys. My keyboard just got stuck. Is it connected? Yes. Awesome. Let's install Sequelize. Give it a second for search. Okay. We have Sequelize package. I'm using 6.26.0. Okay. And we require SQLite 3. SQLite 3. Yes, people. We have SQLite 3 as well. We have installed Sequelize. SQLite 3 also is getting installed. See, your dependencies gets updated whenever you install a new package. Okay, Sequelize, what it does is, suppose in your company, uh, you are asked to switch the database. Okay, suppose in your company you're asked to switch database between SQLite and say Postgres tomorrow. So what Sequelize does it, you do not have to change anything in the code. Just replace Sequelize with Postgres and everything works fine. Okay, it is a wrapper around all the SQL based databases where you get the same APIs to use or same functions to use. Okay, now let us create our database. First, because this is a configuration change, we will put a config folder. Inside config, we will write db.js. Okay, in db.js, we simply have to write constant Sequelize equal to require Sequelize, just like we did yesterday. Right? And now to create a database, a very simple command, simply have a variable create db equal to new Sequelize. Just create a new object for this Sequelize. Okay, it requires some variables. It requires some parameters. First is the database name as a string, username as a string, password as a string, and if you have some options. Okay, let's write test db as the name of the database. Let's put the username as user and password as pass. Okay. Do not use, this is an example, so I can use it. Do not use very common username and passwords because it would be very easy for hackers to hack your database. Okay. Always have a very good password and a very good database, very good username. Okay. Then to make it compatible to SQLite, to make it compatible to the SQLite that we have, we will simply write dialect, okay? And over here, we will write SQLite, okay? Now, if you want to change it to Postgres or you want to change it to MySQL, simply you have to change this string, okay? From SQLite to MySQL or Postgres or whatever. Okay, this is the only change that is required. That is why we are using an ORM. Okay, and we write a host over here. It will be inside config slash db dot sqlite. Okay, this host will create a database. This is how I'm going to show you, and let's export it. I'm going to show you what it does in a little bit. Let's export createDB. Okay. Just like we did yesterday with Express, we simply have to require it. Okay. Create a new instance or create a new object, pass in the database name. We are calling it test database. Okay. Pass in the user, pass in the password, tell it how to connect, okay, or which database you are going to use. We are going to use SQLite for this, and where to put the file, where to put the .sql file, okay, or in this case .sqlite file. So I'm going to put it in config slash db.sqlite. Okay, we are requiring Sequelize destructuring over here because this does not give me a default export. That is why we are destructuring it over here. Understood? Okay. Now we have our configuration set. We have created our database. We have to use or call this function somewhere, right? Let's call it in authroutes.js that we created yesterday. Okay. What was the second step? First, we need to call that function to create a database. So we will call that function, say createDB equal to require from dot slash config slash db. Okay, we have our variable over here. Now we have to call this variable. Okay, to check or and to start the database, we will simply call dot sync function. Okay, this gives us a dot. Then when everything goes as planned, we will simply write console.log database is running. Okay, just like we did with servers in yesterday's class. Okay, we should get databases running over here. See, we have DBs running over here. Okay, and since we have given db.sqlite over here. See, this is an empty file right now. Everything that we are going to write in that we are going to insert will be inserted in db.sqlite. Okay, any doubts? Any doubts? Will the Sequelize create a SQL file once the server is run for the first time or when the DB is made for the first time? When the DB is made. This is basically creating that DB for us and connecting to it and giving us dot then so that whenever everything is done, DB is created, we say that database is running. Okay. Now, what was our next step? We have written this step somewhere, right? Yes. We have created the DB, we have connected to the DB. Now we have to create the models. Okay. Now let's create the models. We create the models in a models folder, right? And we need user models first. Okay. Now how do we create a model? We will simply write, we will simply get model and data types from Sequelize itself. QUE. Okay. Okay. And we will require the create DB from there. So let's require it in a variable called Sequelize. Equal to require from config slash DB. Okay, these two are the prerequisites to create a model. Then we will create a class named user that will extend model. This simply takes the properties of model into our user class. Okay, and then we will say user dot init. This is the function that is given, and inside it we will create our users model. Okay, we have few things: name. Okay, this has a type of data types dot string. Okay, similarly we have email and password with the same thing. We have email and we have password. Okay, and the second option this init function takes is the create DB that we have created, the database name and the table name, which is into model name. Okay, which we are going to call it as user. Okay, all done. Simply return this user. Okay, let's see what we have done. Okay, we require all the methods, all the functions that is written inside the model function, model class. Okay, so we created a class called user and we extended it from model. In this way, all the methods, all the functions that is written inside model class will be inside user as well. Okay, and we have the data types. These data types can be string, boolean, integers, and so on. Okay, then we are given a function called init, which takes two parameters. First, in an object, we write whatever we want. These are the name of the columns. Okay, so there would be a column name in which only the strings can be a value. We have a column named email in which every cell will have the string values. We have password in which all of them would have the string values. Okay. Then we pass the database over here and we write the name of the model as user. This will be the same as table name. Okay. Any doubts in here? Any doubts still here? We have created our DB, we have connected to DB, and we have created our models. Sumit, any doubt till here? Let's revise. Okay. We have created a db.js in which we have created a new database with the name of testdb. We have given the user and password over here, and we have said that we are going to use SQLite as our database. Put whatever we are doing in db.sqlite in the same folder. Okay. Then we connected to it using createdb.sync. This basically creates the database and creates your and up your database, which gives us a promise. In dot then we will simply say db is running. Then we have to create models. We created our models in users. We simply need a class user which extends from model. It gives us a function or a method called init, which accepts two parameters. One is the structure of your table. Okay, these are the name of the columns, name, email, and password. Okay, this will be of a string type. Then it accepts the database and what is the name of your table or model. Okay, we are simply exporting it from here and we are going to import in our routes. Okay, user equal to require from model slash user model. Okay, now this step is also done. We now have to operate the CRUD operations with this user. We are doing Sumit it over here, creativity.sync. Okay, now we have users in the database. We will check it over here. Okay, now if we want to check if the users exist, okay, previously we were checking it in the object keys. Now we have to check in the database. How do I check it in the database? That model will first return a prompt, so we will have to wait for it. Okay, it will take some time, so we will have to wait for it. So we are going to use a wait keyword. Okay, then user dot find or find one. Okay, and inside this, in an object we are going to write where his email is the email that we are getting from request.body. Okay, this will return us, this will find in throughout the table and will return us if any user exists. Okay, find one. See, this model is now giving us new methods. This model is giving us new methods. This is for read. Okay, we have find one. where your email is the email that we are getting from the body. Any doubts? If you are not able to understand, please ping me right now so that I can explain it in maybe a better way. Okay. Now, if we want to, if everything goes as planned, we were saving it over here. Now we will save it in a variable called created user. Okay. Then again, we have to wait for that to complete. User dot create. Okay. Here we will have to create save to db. Okay, this is the user because we are using passwords. So name would be same, email would be same, just the password key would have the hashed password. Okay, and we pass this variable to this. That will create our user. Okay, and we can send this user back to our front end. Okay, this status 201 basically means that it is created, and .send is used to create messages. Okay, any doubts still here? We have seen two things. One is user.create. We simply send the user object inside this in the same way that we have defined our model. Okay, so it accepts a name as a string, email as a string, and password as a string. And to read, we will use user.find1, and inside that, where the condition, where email is the email that we are getting from request.body. Okay, do we check this? Okay, now let's hit sign up. Okay, see, an ID is created for us. Can you guys see? An ID is created for us. An ID of one, name is my name, email is something, password is a hashed password as a string. Okay. Also, we have updated that and created that is created by our DB. Okay. Now, if I try to do sign up again, we will have user already exist. Right? So that means our database is up and running. We see the commands over here. Okay. See, that first search that we are doing over here, user.find1, it gets changed into something like this. Select name from SQLite master where type is table and name is users. If that is not the case, then create table if not exist with these things. And then we got these. Then we have select ID, name, email, password, create table, update table, etc. from users as user where user.email is this, limit is 1, etc. So these functions gets converted into SQL based commands. Can you guys see this? This is the usage of SQLite. Okay. Any doubts? Any doubts? Okay, network tab. Simply right click on your Chrome, go to inspect element, go to network and hit the API. Okay, you will find the API over here. In the headers, you will find the URL, what kind of request it has made, okay, and what is the status code. In the payload, you will see what is the thing that front end is sending. In the preview, you will see what is the thing that backend is sending back to you. All clear? All clear? Sumit, I hope everyone is clear on this. So we have done our 4 steps. Okay. Today's homework would be to perform this CRUD operation. Okay, see more things. There are 2 libraries that you have to learn a lot. First is called Express. In package.json, you will find 2 libraries you have to learn. One is Express and one is Sequelize. Okay, try and experiment a lot on these. Okay, try CRUD operations, try update queries, try read queries, try delete things, try deleting database, try deleting tables. Okay, try deleting only one specific column, try to update the columns. Okay, so this would be your homework or your THA over the weekends. Okay, this should be with your groups. Try to experiment, try to find out more things to learn from. But these 2 things you have to be very fluent on from Monday onwards. Okay, because we are going to be on a project by project basis. So many concepts would be covered in many different projects. Okay, but mostly these 2 things are the most important thing for your interviews or for any of your future projects. Okay, so spend this weekend to learn these 2 things. Okay, I will meet you in the Mahasabha BC. Today's class is okay. Let me tell you one more thing. Let me tell you one more thing. There is something called, okay, there are 2 things that you have to be prepared for. Express, try to read it from the documentation, try to find more examples from Google. Be prepared for SQL and Sequelize. Okay, the database thing. These 2 things are the most important thing. Okay. Sumit, let me answer your query in Mahasabha VC. Okay. There is a thing called, we have learned when we were learning REST APIs that your APIs or the message that you send back should be very detailed. Okay. So there is something called error codes. We have discussed it before also, right? There is something called API codes, response codes, error codes, whatever you want to call it. There are few things that you need to remember. 200 means everything is A-OK. Okay. 201 means modified successfully. Whatever starts from 2 means everything is okay on the backend side. Okay. Other than that, for example, if something is 400, 500, that means something went wrong on the backend. 500 means we do not know what happens. We do not know what happened on the backend. but something went wrong. Okay, 400 series, 400, 403, 401, all this series means that we know exactly what happened. So you need to be very precise while sending the response back to front end, because these things can be seen into your network tab. See the status code. These are called status code. 403 basically means that the user already exists. Okay. If this was 200, that means everything went fine. If I change it somehow and then hit sign up, this is a different user. Name must be longer than two characters. Okay. See, this is 201. 201 means everything is okay and user has been created. Okay. This is the data that I sent. This is the data I have received. See, an ID is already created for us. Okay. And updated at and created at is already created for us. We have defined only these three things: email, name, and password. But these three things are also created for us. Okay. Just for future use. ID, we have learned what it is. Also be very cautious about 201. There are only few status code that you need to be aware of: 200, 201, 400, 401, 403, and 500. Okay, I've already told you what those are. Okay, this was just an extra thing to remember. How do we send it? We send it over here using response.status, whatever the code is, and whatever the specific message is. Be very, very specific with the status codes and the message that you are sending back. Okay, this was all for today's class. Let me meet you in the Mahasabha VC. Okay, peace.